The aerospace superalloy supply chain is structurally fractured by a geographic decoupling of raw extraction and chemical refining. South Africa controls 44% of global chromite ore mining, but holds only 5% of ultra-low-carbon refining capacity. Conversely, China dominates the high-purity refining node with a 55% global capacity share. This dominance exists despite China possessing virtually zero domestic ore reserves. This extreme concentration exposes Western defense industrial bases to single points of failure. Scandinavia represents the West's primary refining alternative, holding 20% of global capacity. This northern European node relies entirely on imported ore, leaving it vulnerable to maritime logistics disruptions. Refining ultra-low-carbon ferrochrome is fundamentally an energy arbitrage business. Smelting a single metric ton requires up to 4,500 kilowatt-hours of electricity. This makes power the dominant variable cost in major refining hubs. South Africa possesses a nominal cost advantage at $2,800 per ton. However, systemic electrical grid instability and load shedding limit local smelter utilization to below 60%. Norway leverages stable hydroelectric power to lower energy costs to $850 per ton. Yet, high labor overhead and the cost of importing raw ore offset these utility savings. This cost structure prevents easy diversification away from carbon-intensive refining hubs. Upstream metallurgical bottlenecks propagate directly into downstream defense procurement delays. Spot prices for high-purity ferrochrome surged over 129.7% between 2020 and 2024. Prices peaked at $4.25 per pound. This price spike reflects energy crises in Europe and power rationing across Chinese smelting hubs. The material deficit has doubled lead times for critical nickel-based superalloy forgings to 56 weeks. Procurement cycles for high-performance, single-crystal turbine blades now stand at an unprecedented 80 weeks. These compounding delays directly stall military jet engine assembly lines and commercial aerospace backlogs. The defense industrial base remains highly vulnerable to these specialized material nodes.